Okay, here's part 2 of 1.3a. We have functions given by formulas. So we now have let g of y equals 3y all divided by y plus 4. It's a rational function. So plugging 0 in should be pretty straightforward. Plugging half in, I'll circle the ones I want you to do for classwork. So pause the video. I know it's kind of at the beginning, but I think you can just do these based on what you learned last video. So that one, CW, is classwork. This one you should be able to do as classwork. I also am pretty confident you could do C. And I think you can even do D, although you have to be careful of a few things. So I'm going to write down the answers for those and do out the steps too. So check back. So try and see how you do. I'll write the answers first, just so you know. The answer for this one should be 0. The second one should be 1/3. And g of -4 comes out to be undefined or does not exist, is what I think my open math has you do a lot of times. D, I'm not going to tell you yet because I don't want to give it away. So hopefully you paused and tried them and you're checking your answers. And then now I'm going to go write out the steps and you can check back on those. Okay, so they're all written out here. I want to point out a couple of things. Don't leave your answer just as 0/4. Make sure you do write 0. For number 2b, you can clear the fraction, the denominator in the fraction, by multiplying top and bottom by 2/2. And then I get 3/9. Always make sure you reduce. On this part C, -12/0, again, don't leave it. Make sure you write DNE for does not exist or undefined. You could write also. Part D, be careful. We're just going to plug in the expression here, y plus 2, everywhere we see the y. Take care not to do bad canceling. Bad canceling would be something like, oh, those are the same, so I'm just going to cross them out. Doesn't work that way. You can only do factors with factors, not terms with terms. See, this plus separates that y plus 2 out, so can't have that. You can distribute this and get 3y plus 6 in the numerator, and then combine like terms here to get y plus 6 in the denominator. Again, you wouldn't ever just go like, oh, slash those out. If you're not sure why that is, I do have a video I made for a different class on how come that doesn't work. Anytime, just fill numbers in and see what happens. It won't come out true if you just kind of slash out one thing. You guys probably know that at this point. You've learned it. It's just sometimes you forget and it's tempting to look back. But just email me if you want more information on that and I will send it to you. Usually don't post that in the pre-calc, but in your module, but I'm happy to talk with you about it separately, or email me and I'll send you a video. So part E, now we have g of y plus 2. Again, I'm going to carry down, I'm going to write in red what our original was there. Okay, so here's our g of y equals 3y all over y plus 4. And we're going to find g of y plus 2. So it's really just as simple as it looks. People tend to want to do something different here, but it's the function plus 2. So the function is 3y, y plus 4. That's how it's represented, right? So then we just add 2. So here we have g of 2 over y. So we're going to plug in 2 over y everywhere we have a y. One thing that I notice students tend to do is they want to multiply 3 times 2 and 3 times y, but keep in mind it's not 3 over 3 that we have, it's 3 over 1. So if you tend to just quickly look at that and get it wrong, just put it over 1. We'll solve that problem. And now, not too much to do really to simplify. There's a couple of different routes you could go. I'm going to multiply here, so I have 6 over y, and then I have 2y plus 4. And I can clear the fractions. Because I have a fraction, I can multiply top and bottom by y over y. That's my common denominator. So then I'll get these two to cancel out. And then this one I have to be careful because I do have to distribute to both of those. So this denominator will cancel, but that one's over 1. So I didn't have anything there. So how that works is I will get 6 over 2 plus 4y. So if I write them out separately, let me write it instead of, say I already distributed, instead of having it that way, multiply both these terms by y. That's where I get my 2 plus 4y. So that's clearing the fractions or simplifying a complex rational. And this is what I'm left with here. Okay, so now we're going to go back up to the top right of the worksheet. Find g of y all squared. So what we want to do here is take our whole function, which is 3y over y plus 4, and put parentheses around it and square the entire thing. Now be careful, make sure you apply your product to power rule accurately. So it's 3 squared times y squared, so that would be 9y squared, not just 3y squared. Then we have y plus 4 all squared. You can leave it like that for most of these. I don't have you expand it out. Probably won't help you simplify anything. Again, be careful not to be like, oh, I see 2 y's, I'm going to cross them out. That would be incorrect. So don't try to force it to simplify. Remember, factors with factors. If we have anything separated by a term, or even this one's a binomial squared, so that's a lot more involved. We can't just slash out things that look the same. Okay, now let's take a look at how that one differs from h, which is g of y squared. Okay, for this one, find g of y squared. I want you to pause and try that one on your own. So it's labeled CW, and then you can go back and check it. I'm going to move on to letter I momentarily, but just pause the video and try H. Okay, so the answer for H, you're just going to plug in y squared wherever you see y, and that is it for that one. Okay, don't try to just cancel terms with terms. We can't do that. So for I, find g of y plus z minus g of y all divided by z. And it says, what is this? Do you recognize that as anything specific? Think about that. I have the original, again, written right over here in red so we can reference it. And this one is a long problem. It's similar to one we did before, but now we have, it's just a lot more complicated because we have all these letters. So g of y plus z and its fraction. So we're going to plug in that to our function. So we have 3 times y plus z. I'm plugging y plus z in for y. And then I have all divided by y plus 4. So y plus 4 is, I have to put in y plus z instead of y, right? So the y plus 4 is over here. But instead of y, I'm putting in y plus z, then plus my 4. Okay, so that's a little tricky to remember. And then I'm going to put this in brackets so I keep track of it, and subtract my function, just g of y, which is 3y, all divided by y plus 4. And then the whole thing is divided by z. And this is called the difference quotient. And there's a pattern to it that I want you to start paying attention to, and you'll do more with that in calculus as well. So first thing we want to try to do is streamline this. We can multiply top and bottom by our lowest common denominator, because remember this is like a 1, right? So our lowest common denominator would be y plus z plus 4. I'm going to remove this parenthesis because we don't really need that. So if we multiply and distribute, y plus z plus 4 is one of our factors. And our other one is y plus 4. So if we were to distribute, that's the same as multiplying every term by that. So I'm just going to take a little shortcut here instead of rewriting it. And then we have y plus 4. And then we also have to multiply the bottom because we can't just do 1. We have to balance. It's like multiplying by 1. Y plus z plus 4 over y plus 4. So we've really multiplied by 1, and then we distributed in the top. You should be pretty familiar with how to simplify complex rationals from the beginning stuff that we did in prior courses, but let me know if you have more questions on that. So now we're going to simplify. So y plus 4 and y plus 4 will reduce. Y plus z plus 4 reduces there. So now I'm left with, let me get this out of the way for now. We have this 3y plus z in the numerator times y plus 4. And then I have minus 3y times y plus z plus 4, all divided by z times y plus z plus 4 times y plus 4, because nothing canceled on that one. We just had a 1 in the denominator, so I don't have anything that, reduces out. So I just leave that. Then I can actually start streamlining. I can do these out. I want to multiply and expand that. And okay, so now we've expanded some things out. We took the these two binomials, foiled them, and we get y squared plus 4y plus yz plus 4z. And then distribute this negative here, negative 3y, and get minus 3y minus 3yz minus 12y. That's really important to have those opposite signs. That way everything will cancel here, literally go to 0 once I also distribute this 3. So here's where I did that. I get 3y squared and a minus 3y squared. So I can literally just cross those out. They go to 0. 12y with the, well, that should be a minus in there. Let me just fix that. So that should be a minus. So we have a minus 3yz and a minus 12y. And so those also reduce out to 0. So all I'm left with in the numerator is 12z. Let's make that look more like a 2. 12z. And then in the denominator, I have a z. So I can actually reduce those z's to 1 because now I'm just left with none of this. That's all gone, right? So I have a factor with a factor, and I can reduce it. And so my final answer is going to be 12 divided by y plus z plus 4 times y plus 4. And that's called the difference quotient. And a lot of times we have an h that we work with. So you may see that again, probably on a quiz, maybe a test. So be aware of that and know how to show out all your steps. Those are tricky. So I can take more questions on that if you want. Okay, so for the last one here, J, I'm just gonna bump it down to a clean spot. And we have solve g of y equals 3. So again, g of y is equivalent to 3y over y plus 4. So I'm going to write that here. 3y over y plus 4 equals 3. And then I'm going to solve. And I can actually do that just by cross multiplying. If I put this one over 1, put parentheses around your denominator. Remember, that's a grouping symbol, is a denominator or numerator. And then I'm going to actually cross multiply, or you could clear the denominator, whatever you want to call it. And so I would have 3 times y plus 4 equals 3y. Distribute, I get 3y plus 12 equals 3y. And then I get 12. Oh, this is kind of odd, right? I can subtract 3y from both sides. And I end up getting 12 equals 0, which is an untrue statement. So therefore, that means there's no solution. Okay, so we can't have that ever equaling 3. And it's probably due to an undefined situation there. Okay, so that's it for the brunt of what I wanted to go over. This is getting kind of long. So I think the last couple of problems, with the word problem and this f of x equals radical 3x, and find the difference quotient for that. So I will do those in a separate, just a supplemental thing, maybe as extra practice, but I'm not going to require you to do that. So I'll just post that separately, not required for notes. And we'll do it later. Okay. So I'll just post that in maybe an activity review kind of assignment or something like that. Not necessarily, or maybe I'll do it in, I could do it in the Zoom session or something. So that's good for today. I really wanted to go through a lot of this algebra of functions because they are kind of tricky to work through, and I wanted you to see lots more examples and have more experience with that. So have a great day. Thanks for watching.